Okay, so our first example of a function of two variables is this one. So let's describe f of xy equals 2 minus x plus 2y geometrically. So when I say geometrically, what I mean is I'm sort of assuming that z is f of xy, right? So this is an assumption that we made in the last slide. Graphically, if we want to graph these things, then we can assume that we're taking things from the plane, from the xy plane, and we're outputting some f of xy. And I guess the idea is that if we take enough of these things, we might start to see some shape unfolding upstairs, so some surface. So we'll talk a little bit more about these as we go, and a little bit less, a little bit more abstract examples. But let's look at an example that might be familiar to us. So if we let z equal f of xy, then we're really looking at z equals 2 minus x plus 2y. And this might start to look familiar because if we swing things around a little bit, this is x minus 2, let's even put that in parentheses, minus 2y plus z is equal to 0. And if you remember from 2 classes ago, this is the equation of a plane. So we already know geometrically what this should look like. Let's just maybe, while we're here, we'll collect some information about this plane. This plane, for example, goes through the point 2, 0, 0. So plane through 2, 0, 0. And let's see what else. It's normal. Remember, its normal is the coefficients here, right? This coefficient, this coefficient, this coefficient. So its normal is going to be 1, negative 2, 1. That's some vector that, that is perpendicular to every point on the plane. And so if we look at maybe an example of this, very shoddily drawn, 2, 0, 0, that's this point here, 2 in the x direction, 0 up, 0 over. And 1, 2, negative 1. Let's maybe try to graph that. That's 1 in the x direction, 2 in the y direction, negative 1 is down. And so this should look something like this. I'm not going to try to draw this plane, or maybe I'll give you some really crappy drawing of it. It's not to scale. Another way that we could do this is maybe find 3 points on this. That might be more convenient for graphing purposes, but I really just wanted to know geometrically what this looks like. And geometrically, it's a plane through the point 2, 0, 0 with normal 1, negative 2, 1. So here's just proof positive that you've actually been dealing with these things before. It's just that we're going to be taking a more complicated look at them now, and we'll be talking about domain of these as we go.